Hey guys, what's going on? So here's another video. It's going to try and encompass everything that we've learned over the last couple of weeks for converting and naming. So try and pay attention. Remember, it's a video, so if you want to pause, rewind, or fast forward, you can always do so. Okay, so here's the problem. We were given 8.14 times 10 to the negative 6 grams of sodium carbonate, right? And we want to convert to atoms of sodium carbonate. Well, a couple of things we got to take care of first, right? In this problem, we need to first understand that we're going from grams to atoms. Now, if we're going from grams to atoms, we must first go to what? We first must convert to moles. Remember, you have to go from grams to moles to atoms. All right, so always keep that in mind. You have to start here and work your way this way. You can't go directly from grams to atoms, right? We don't have enough math to do that yet. Okay, so let's get started. Let's see here. Now, what we have in this problem is we have a compound. Now, because we have a compound, we have a name, we first have to figure out what is the chemical formula for sodium carbonate. Now, at this point, we know that this is obviously going to be a compound, right? I mean, you have at least two elements, and we know that anything with more than one element is going to be a compound. So let's try and ask ourselves a few questions first, right? Now, the first question we want to ask ourselves is what type, right, of element is this? It's going to be one of two types. It's either going to be an ionic compound, right, or it's going to be covalent. Right? How do you know if it's ionic or if it's covalent? Well, there's a couple things that kind of give it away. Right? First thing you want to ask yourself, is there a metal? Is there a metal in this compound? Or is the compound made of all non-metals? Now, do you guys remember that I told you that most of the elements on the periodic table are in fact metals? And if you look at your little periodic table, it kind of looks like this, right? A real quick one, right? Pretty much the whole table is metals except for this part right here, right? So if your elements are all in this part here, then you're all nonmetals. And if your elements exist in all this over here, right, then you're going to be a metal. Now, one of the things that I noticed is that we have sodium right there. See it? So sodium is kind of over here. I'm gonna white it out here. So because I know that sodium is over there, it's in group 1, right? I know that it's an alkali metal, right? So because this has a metal, now I kind of know that this compound is going to be ionic, right? Okay, so if it's going to be ionic, it can be one of two types of ionic compounds. It can either be an ionic binary, right? Or it can be an ionic polyatomic. Right, those are the ones that I told you guys to memorize, which you guys didn't listen, but hopefully you will soon. All right, so just bear with me. I'm gonna just kind of shrink this down a little bit. All right, kind of got that out of the way here. So let's pick up where we left off. Like I said, it can either be binary or it can be polyatomic. So how do we tell the difference? Well, here's your clue. If one of the compounds ends with ATE or ITE, it's going to be polyatomic, right? If the compound or the second compound ends with an IDE, ide, chloride, fluoride, things like that, then this compound is going to be binary, right? All right, so what do we see? We have, so let's write the compound real quick. We have sodium. We know what this guy looks like, Na, and we have carbonate, right? Sodium carbonate. Now, I see the ATE ending, so because I see the ATE ending, I'm going to assume that this guy's polyatomic. So now I have to go back to my list and figure out what this compound looks like. What does carbonate look like? Well, carbonate is CO3 1 minus, and sodium is Na1 plus, right? So now we know that this is an ionic compound because we said it was ionic, has a metal and a non-metal. So we know it's going to bond using those charges, right? So where do those charges come into play? Well, we should know this already. We know that this number becomes the subscript over here, and this number becomes the subscript over there, and this compound is Na1 CO3 1, but because the ones are understood, we just write it as NaCO3. Yes? Okay. So now we know what our compound looks like. It's right here, right? So now we're going to start off by converting from grams to moles, right? Now, in order for us to do that, right, we have to figure out, first thing, we have to do molar mass. You guys remember this? We have to find molar mass, right? So remember I told you guys, if you see the G for grams, the G tells you to go to the periodic table and find that atomic mass. Well, the atomic mass works if you're converting with elements, but because we have a compound, now we have to find the molar mass, which is what we're going to do real quick. Molar mass. So first thing you want to do is you want to list all the elements involved in your compound. So in this case, it's sodium, it's carbon, and it's oxygen. Right? Then what you want to do is you want to figure out what is their individual atomic masses, and you get those from the periodic table. I know that sodium is 22.9. I know that carbon is 12, and I know that oxygen is 16, right? In this case, you can round up to the next whole number. That's not a big deal. So here we have 22.9, and then you have to multiply by the number of each one that you have in the compound. So I know that I have the sodium, so 22.9 times 1 is going to be 22.9 grams per mole, right? 12 by 1 is going to be 12 grams per mole. And I know that 16 by, in this case, actually it's 3 because there's 3 oxygens, right? It's going to be 16, 32, 48. So that's going to give me 48 grams per mole. Okay, then all we have to do now is just add everything up, right? So we got these guys all added up, and that ended up being 82.9 grams per mole. Now, I like this unit, the grams per mole, because it tells you everything you need to know. If you see the unit grams per mole, that's basically telling you, it's giving you the conversion factor, right? Because it's telling you that for every 1 mole of sodium carbonate that you have, that has a mass of 82.9 grams, right? So here's your conversion factor. So let's set up our problem, right? We're going to do dimensional analysis. I know you guys don't like to do it, but this is the easiest way to do it. We said that we had let's see, it was 8.14, 8.14 times 10 to the negative 6 grams of sodium carbonate. Right? So this is our conversion factor, right? This is our conversion factor is here. So let's set it up, right? We got to first go to moles. So I'm going to do my little table, and I'm going to do my conversion factor. Now here I have 2 values, right? Let me see if I can underline these for you. Here, okay. Here I have 2 values. I have 1 value here, and I have 1 value here. And here I have 2 empty spaces, right? So you have to try and determine which one goes where, right? Now, this is the way I do it, right? I always list them as units that I want over units that I already have. Or if I have a unit here, whatever unit this is, it's the same unit I'm going to put down here. So in this case, right, the unit that I have, or the unit, is grams. So if I have grams here, I have to put grams down here. Which one of these 2 represents grams? Well, it's this one, right? So because that's the one that has grams, I'm going to put 82.9 grams, right, of sodium carbonate, sorry. And then the other one goes on top. If the grams is on bottom, then the other one obviously has to go on top. So 1 mole is that many grams, right? Always over 1. Okay, so what happens next? Well, at this point, then we just have to multiply 8.14, right? Let's see. We multiply 8.14 times 1 times 82.9, and when you get those set up together, this is kind of what it looks like. You have 8.14 times 10 to the negative 6, right, divided by 82.9. And this is going to be grams of NaCO3, right? And that's going to be divided by no units, right? Because the units canceled out here, right? When you get the answer, your answer is always going to be in moles because that's the only unit that's left, right? So I'm going to divide it out real quick. That's going to give me 8.14. Exponent -6. I'm going to divide that by 82.9, and that's going to give me 9.81 times 10 to the -8. This is going to be moles of sodium carbonate. Keep saying that, I don't know why. So there's my moles. All right. Okay, so just shuffling some stuff around here real quick. All right, so let's start off again. We have 9.81 times 10 to the -8. That's what we figured out, right? Times 10 to the -8 moles of sodium. See, I almost said it again. Carbonate, right? So here it is. Now we have our moles. So now we can go to atoms. Now, remember I told you guys in class, if you see atoms, the A for atoms is equal to Avogadro. So whenever you're going to go to atoms, you always use Avogadro's number. So let's write our conversion factor real quick. Our conversion factor here is going to be 1 mole of anything, right? Is always going to be 6.022 times 10 to the 23rd. Atoms of whatever it is, right? So I'm not going to write the compound here because this is just our generic conversion factor and we always know it's going to be the same. All right, so I'm going to just kind of zoom this down a little bit so I can get it out of my way, and then we'll go ahead and start again with our given. Remember, our given always goes over 1, so it's 9.81 times 10 to the -8, right? Moles of sodium carbonate. All right, so there it is, right? So I'm going to set up my conversion. So once again, here's my conversion factor. I know it's a little small, but it's 2 values and I have 2 spaces. It's units that I want over units that I have, right? Or in this case, if I have moles here, then the moles go at the bottom. 1 mole of sodium carbonate, right, is 6.022 times 10 to the 23rd atoms of sodium carbonate. All right, so there it is. Let me see if I can write a little bit bigger. I know that's a little small. All right, so what happens next is essentially it's just a math problem. Yeah, we're multiplying fractions. Let me get my little pen out here. Okay, now first thing I want you to take notice is you have the moles here. These moles cancel out these moles, right? So if those moles get canceled out, then the only unit left is atoms. Oh, sorry, lost my pen again. So let's multiply this out, right? We have 9.81 times 10 to the -8, and we're going to multiply that, it no longer has units, by 6.022 times 10 to the 23rd, right? This guy still has units, and that's atoms, all right? And then we're going to multiply 1 times 1. So when you simplify all this, you end up with, let's see, 5.907 times 10 to the 16 atoms of sodium. I don't know why I keep doing that. Sodium carbonate. Right, and then divide all that by 1. Of course, anything divided by 1 just gives you the same number again. I'm going to zoom this down a little bit to get it out of my way. Okay, so take this one down a little bit, get that out of my way. So essentially what ends up happening is this divided by this gives me the same number again. So I end up with 5.907 times 10 to the 16 atoms of, I'm going to say it right this time, sodium carbonate. There it is. So we've just taken a value in grams and we've converted it to atoms, right? We had to find the molar mass. We had to convert from grams to moles, and then once we figured out grams to moles, we went from moles to atoms. And then on top of everything else, we had to figure out what the compound looked like, right? Now, hey guys, listen, I get it. This video is longer than most of the other ones. Just try and be patient. Remember, you can pause it, rewind it, fast forward, stop it for one part, get that down really well, and then start the video all over again, so you don't have to kind of sit through this marathon. All right, if you guys have any questions, let me know. I know it's a lot of work, but I told you guys, chemistry only, it's going to get tougher. So work it out. Let me know. Later, guys.